Hey everyone, I'm Anthony. I'm here to present to you guys something we've been working on for some time now. This is a first of its kind idea of persisting or offering a persistence layer to NetworkX through ArangoDB. And so the whole motivation here was we want to basically demonstrate the symbiotic relationship that ArangoDB can have with NetworkX and QGraph. Because on one hand, you have NetworkX and QGraph being the standard libraries for graph analytics in Python. They're extremely easy to use, they're open source, and so the onboarding time is very, very quick. And on the other side, you've got ArangoDB's multi-model capabilities wrapped in a single query language, also open source and highly scalable. So we see a good fit and a good relationship to actually have between these three technologies. And so on one hand, NetworkX users gain a storage interface, the ability to talk to ArangoDB without needing to leave NetworkX. They also get to inherit graph visualization tools and graph querying tools, and just the general ability to persist and reload data whenever needed. And so this is useful when working across teams with different sessions. So it really simplifies the life of these data scientists working with NetworkX. They don't need to reload the data into a graph every time. The data is persisted somewhere, and they just can read it from the DB. On the right side here, you've got, the benefit for ArangoDB users. So formally, if they're not used to NetworkX, they now can access NetworkX and continue to use their data while kept in ArangoDB. So they have a bunch of algorithms at their disposal now: PageRank, harmonic centrality, betweenness centrality, shortest path, all those things. And they could continue to use NetworkX while also leveraging the GPU accelerated version, which is now known as QGraph, and more specifically through the use of this NetworkX QGraph backend that NVIDIA recently announced. So we've been working closely with NVIDIA to make sure that that transition from ArangoDB to GPU algorithms is as seamless as possible with limited code change. Okay, so at the moment, how it stands is we've got this NetworkX and QGraph relationship where users interact with NetworkX and can optionally, dispatch the algorithms to QGraph for GPU acceleration. What we're trying to propose is the same thing, but adding an ArangoDB instance to this architecture so that we have a persistence layer where we can take advantage of all the cool things that ArangoDB offers and continue to use NetworkX, and having just that confidence that your data is stored somewhere while you're working with NetworkX graphs. So from a quick highlight, we'll go through a few of these slides here to showcase some code snippets. Graph instantiation doesn't change too much. What you're only expected to do now is pass environment credentials to specify the instance, the connection credentials of your ArangoDB instance. Here we have one running on our local host machine, and so you'll see that the graph instantiation doesn't look too different from the NetworkX graph instantiation. The constructor is the same. All we're doing is we're passing here an existing NetworkX Karate Club graph. We're specifying the graph name, and we're saying that we want the node type to be called person, which is going to be the vertex collection that's going to exist in our ArangoDB database. From a CRUD perspective, nothing changes. Everything that you would previously used to do in NetworkX graphs, you can do in NetworkX ArangoDB graphs: adding nodes, deleting nodes, fetching the adjacency of a certain node, updating nodes, deleting. So anything that you would previously be able to do in CRUD for NetworkX, you could still do in NetworkX ArangoDB. And so, of course, the GIF you see on the right here shows where we're making updates to certain nodes or edges, and you can expect those changes to be reflected in the DB in real time. From an algorithm perspective, no change at all whatsoever. We have a demo here showcasing PageRank on the ArangoDB graph that we instantiated in the last slide. And then we're iterating through the results of those PageRank, the PageRank values, and storing them back as attributes in the documents. And so invoking a NetworkX algorithm is no different on an ArangoDB graph than it is on a NetworkX graph. We also like to propose the concept of a remote algorithm, which means triggering an algorithm that already exists via ArangoDB's features or analytics tooling, so that you don't need to actually pull the graph into memory, therefore, establishing this concept of a remote algorithm. From a GPU perspective, we're switching data sets really quickly. This data set is from the Snap website. It's used in NVIDIA's blog post to talk about NetworkX QGraph. It's about 16.7 million or 16.5 million nodes, edges, and 3.7 million nodes. Here we can see running PageRank and betweenness centrality on this graph while stored in ArangoDB. It takes about 30 seconds to run the graph, to run the algorithm in total. So that's around 25, 30 seconds to load the graph from ArangoDB to QGraph and another 4 or 5 seconds to run the algorithm of your choosing. Of course, this is tested on a T4 GPU, which you can see on the top right of that Google Colab GIF. Of course, what kind of demo would it be without LLM? So because ArangoDB has this close relationship with LangChain and through its LangChain integration pack, we're able to now offer a natural language experience to NetworkX users, which previously did not exist. And this is simply because of the byproduct of now having your graph stored in ArangoDB. So NetworkX users can now literally talk to their NetworkX graphs and receive a natural language response, which is a very useful, a nice thing to have when you don't feel like using AQL, for instance, or using the NetworkX CRUD capabilities. You can just plug the LLM you want to use and ask away. So getting started with ArangoDB is very simple. You've got 3 options at your disposal, with the community edition being the easiest, with a quick Docker command to get started on localhost. You can also use a temporary enterprise edition, which will run for around 3-4 hours if you want something in the cloud. Just use the pip install package that we offer right there. Of course, we offer ArangoGraph, which is the cloud managed service of ArangoDB, with a 14-day trial. Thank you.